Hello YouTube, welcome back to my channel. So this is the beginning of this tutorial is the beginning of a new series on my YouTube channel. We are going to go over a series called on machine learning. So this is the first tutorial in this series. So in this tutorial, we're going to be learning linear regression. We're going to look at the two types of linear regression, the one containing a single variable and then the multivariate linear regression. So at the end of this tutorial, I'm also going to give out an assignment which you can find on this link right here, which is a GitHub. Which will be on my GitHub page, and I also give a further reading on how to evaluate your regression model right here, and for those who are curious and want to learn how to evaluate their model. So let's get started. So the link to this notebook, Jupyter notebook, is in the description below, so you can just go there and you can find the Jupyter notebook. Okay, so in high school, you might have probably come across this formula, right? Y equals to mx plus b. So this formula is a very, very famous formula. It's called the formula for the linear regression, right? So we have the y, which is the predicted value or the dependent variable, because its value depends on the values of x, mx, and b, and that's why it's called the dependent value. And then the variable, and then you have m, which is the slope, and then x, which is the dependent variable, and then the b, which is the intercept, right, where the graph is. Okay, so we'll be using this formula to build a machine learning model which will be able to predict the price of a car when given the engine size of the car, when given the cc of the car. So that's what you're going to be doing in today's tutorial. Okay, but before we go there, let's try to understand some terminology. So imagine that I have these points on the Cartesian plane, right? And I want to ask you to draw the base fit line. So someone will draw this line, right? And then another person might draw this line, and then another person might draw this line. Okay, so the question is, what is the base fit line? How do you know whether this line is the base fit, this line is the base fit, or this line is the base fit? How can you determine this mathematically, right? So that's the big question. That's the question that if you're able to answer this question, then your predictions from your graphs will be much more accurate, right? So that's what we'll try to do. So to understand this, we'll first look at something known as residuals. Okay, so let's imagine that you have these points, these blue points, right, on the Cartesian plane, and then you draw the base fit line, which is the black line. Okay, so you draw a horizontal line from the points to the line, to the touch of the line. Okay, so the points on the line is known as the predicted values, and the y are known as the truth values. Okay, so to find the residual, a residual is a difference between the truth value and the predicted value, right? So if you can draw a line that has the lowest amount of sum of residuals, so the sum of the residuals will be R1 plus R2 plus R3, right, which will be the residuals, right? So y truth minus y predicts is known as a residual. So the sum of it and the square of it is known as the sum of the squared residuals. So if you can draw a base fit line that will have the lowest residual errors, then that is the base fit line, right? That is known as the base fit line. We find this known as using the least square method. Okay, so this is known as the least squared line. So let's go ahead and look into the formula to find the sum of squared residuals. So this is commonly known as a residual sum of squares, but I call it sum of squared residuals because it makes much more sense, and some books also call it sum of squared residuals, but is mostly referred to as RSS, residual sum of squares. So this is the formula, right? So we take the y truth minus the y prediction. So the y prediction is the value that you get as after passing the certain x into a function, right? You get that, you square it, you find the RSS. So that's the formula for finding the RSS. Okay, so let's move on to another part of this equation of this tutorial. So we have done a look at for the theory behind the RSS, how we can use it to calculate the base fit line and stuff like that. So now let's move on and look at the libraries that we need, and we can begin to code. So we'll be using pandas in this tutorial, and also we'll be using you also need to know Seaborn or Matplotlib. So if you follow my channel, I have been making videos on pandas, so you can just click this link and it will take you to that tutorial, the first tutorial in the series. And I also have a tutorial on data visualization using Seaborn. You can also check out that video. Okay, so we'll also be using a library known as Scikit-learn. So Scikit-learn is a machine learning library, go-to machine learning library for Python. So I'll also you can click on this link here in the notebook, and it will show you the video on how to install that. Or I also keep a card up here, and you can find the video on how to install all the libraries, include Pandas, Seaborn, and Scikit-learn. So all the libraries will be using in this tutorial. You can install it through this video. I'll place a card here. You just click on that card, and it will take you to that video on how to install all these libraries. So take this code there and then install those libraries. Okay. So or if you also have an Anaconda installed, then you probably already have these libraries installed. But if you don't have an Anaconda, just go and watch that video and install those libraries. So I assume that you already have those libraries installed. So let's continue going. So in this what we'll be solving is that we'll be creating a machine learning model, an ML model, that will predict the price of a car given the CC of the car. Okay, so that's the question that we are going to be trying, the mystery that we're going to be trying to solving. Okay, so let's get to it. So now let's get to the code. So I'll just exit this, and then we can begin to code. Okay, so let me just scroll down here, and I'll make a new Jupyter notebook. So we'll first need to import the libraries that we'll be using, right? So don't worry about this. We'll go over it just in a second, but just focus on the code right now. So we're going to be importing Seaborn as SNS, and then we also import Pandas as PD, and then we also import this the scikit library that we'll be using. Okay, so just go. We need to import a linear model, one of the models from scikit-learn. So just say from sklearn import it's called the linear underscore model. Okay, this will import first the linear model. Okay, if you are new to sklearn and you want to read more about scikit-learn, you can just go to their official website, sklearn.org, and then you can read about their different models. Okay, so let's jump back to our tutorial. So now that you have done that, we can just go ahead and run this out. We didn't get any error, so that shows everything is okay. So now let's go ahead and actually import the data frame, so our CSV file. So just go pd .read CSV. Okay, if you don't know what I'm doing here, you can just go back and watch my tutorial on pandas. Okay, so I stored it and called it datasets. I call it car price. I think it's prices. Prices.csv. Yeah, I believe they call it that. Yeah, I got an error. So let's look what the error is. There's no file like that. So let me think. I think I called it let me just prices. Yeah, I called it data sets, and then car prices cc.csv. Okay, so you can find this file on the GitHub link. Okay, so you can just go ahead and get that file and follow along. So now that you have got that, we have loaded our data frame. So let's just take a look at the data frame. So it's just a short data frame that I made myself. It's just about 10 rows of data. So now that we have that, we can also look at the df.shape. This return to us like the shape of the data. So this is not a method, this is an attribute. So now we have done that. It's just 9 rows. I just made it myself and containing of 3 columns. So let's try to visualize our data, and then I'll be able to explain to you something. So sns.joint plot. So I'm going to make a joint plot, which will just be df. On the y-axis will be df.prices, price, just like this, and then on the y-axis will be df, and we are going to draw against the cc column, which is the engine size. Okay, and then you're going to specify the data to be the data frame, and then you also specify the kind to be of type of reg plot. Okay, because I want that regression line. So we'll run that code, and you can see we have that right there. So these are our points, right? And this is the best fit line. So Seaborn automatically calculates the best fit line for you in the background, but we want the equation to this best fit line so that we can be able to make predictions. So that's what scikit-learn is going to help us to do. Okay, so this is the best fit line, or the least square line. Okay, so now let's go ahead and actually write Seaborn code that can mathematically give us the equation for this line. Okay, so now that you have done that, we simply go ahead and actually create our model. So I'll call this linear, and then we'll say linear models. Sorry, this is linear underscore models. dot the model is called linear regression, and then linear regression, and then we'll simply just run this code. So this will create for us the linear regression model. So now we have created our model. Now we need to train our model, right? So we need to train it. So train it is called fitting the model. So we need to fit it with the x and the y values. But what are the x and what are the y values? Okay. So now let me just remove this for now. So we want to predict the y, right? Our y is a predicted variable as we looked in the slide earlier. So y is a predicted value, and we want to predict the price when given the CC of the car. Okay, so we are going to, the price will be our y-axis, the predicted value or the dependent variable, and then the CC will be the independent variable. Okay, so this will be the x-axis, and this will be the y-axis, and this will be the x-axis. So let's try to do that. So I'll just say x equals to df. I'll use it. I want a data frame, so I'll use the double for that. And then I'll say CC, and then now we want to go ahead and actually do the y. Y will just be df. This will just be a simple series, which will just be the price, right? We run that. So we can go ahead and actually look at x, x, which is just a data frame, and you can go ahead and look at y, which is just a series. So now that you have done our model, let's go ahead and actually train that model. So training the model is called fitting the model. So we just say fit, and then we're providing the x, y. So run that. Our model has already been trained, just like that. So quite simple, right? So now that you have done that, you can go ahead and actually make predictions. So our model knows the relation between the CC and the price, and it has the formulas y equals to mx plus c. It understands this formula for this specific scenario. So we can now do a prediction. So we want to predict the price of let's just go back in here. Let's try to predict the price of of this car, which has a CC of 16,400. Okay, so just move down here and paste that, and make sure that this is a 2D array. So just run that. So it has predicted the price of the car to be 1413. So we can move up here. It's actually the price is actually 1400. So it's just very almost accurate, right? So it just has an error of $13. Okay, so that's these are prices in dollars. So it just has an error of $13. So our model is quite accurate, right? So now we can be able to make predictions of different prices when given a house. So let's try to make a prediction of the car that will cost. Let me say a car that will cost that has a CC of 14 like this, of 1400. So the price will be 1400, about $1,406. So that's how we can be able to make a machine learning model that can understand data and be able to make predictions. Okay, so but how is this working? Why is it making this prediction? What is happening in the background? Okay, so as I explained to you earlier, right? So let me just make this a markdown. So I'll type in here some markdown formula. So y equals to put this in, y equals to mx plus b, right? So this is a formula that we have been using. So let me try to make this a bit larger. So we're saying y equals to mx plus b, right? So the x-axis is coming, the x variable will be what we have provided in here. So what is the slope and what is the b-intercept? So this is what our model has calculated in the background whenever we did the fit method. So whenever you do the fit method, the model uses all the data and tries to figure out x and y and the best fit line. Okay, so now let's try to see what's the coefficient. So this is say lim reg dot coef underscore. So this will return to us the coefficient, right? So the coefficient in this case is just x, right? So x is a coefficient. So the coefficient is 0.0 this value. And then let's try to look at the y-intercept of this graph, which the model drew in the background. So intercept and then underscore. We run this model. So this is the y-intercept for this graph. So b is this, and then y is that. So let's just put it in this way. So just say x. Let's write a function that will be able to predict for something for ourselves. So my pred. So we just take in call the CC, and then we just say y equals to the slope value, which is the slope value, which is the coefficient right here. So I'll copy this value and I'll paste it here. And then we need now the x-axis, which will be multiplied by the CC, which will be provided in, and then we get plus the b-intercept, which is the y-intercept, which is here. So we paste that here, and we'll simply return y. So that's our function. So let's go ahead and actually call my predict, and then we pass in let's pass in this value right here. So this will copy it, and then we'll paste it right here. So I'll paste it in here, and then I'll run the model, and we can see we got back the same value as the model predicted. So that's how it works in the background, right? So these values are the same. So that's how it works in the background. So it's just common base high school mathematics that is used to make a linear regression to train a machine so that it can be able to understand data. So now that you have looked at a simple single variable linear regression that contains multiple values, just a single value. Okay, so now let's move on to imagine that the mileage also affects the price of the car. So the mileage and the CC play a role in the price of the car. So how can we do that? So that's let's go back up here, and then I'll explain to you something. So I'll move forward right, so here, and then this is now known as multivariate linear regression. So whenever you have a linear regression having multiple variables, is known as a multivariate linear regression. So what's the formula for that? So in the previous tutorial, when you saw the single variable linear regression, we had only one of these, right, and then plus the constant. But now there are many of those variables who have multiple of them, right? So the b times the coefficient of b2 times the coefficient of times x2, and then we have the coefficient of bn times xn, and then we have 1 as slope. So that's how the formula is for multivariate linear regression. So now let's build a model that can predict the price of a house, the price of the price of our vehicle when given the CC and the mileage of that vehicle. So all we need to do, we can come here and just go lin reg, I'll call it reg 2. This should just be linear, call it from linear. Just move that out of there. So linear underscore model dot linear. This is make sure you watch the capitalization regression. That to create a new regression for us and a new machine learning model. So we'll go ahead and actually train our model. So new reg 2, right? New reg 2, and then dot fit. So we need to fit it. So but before we fit it, we need to have the x and the y. So let's call it x, xy, x1. Let's call it x2, which will be equals to df. We want two things, right? So we want the mileage, which is in kilometers, so kilometers. And then we also want the CC, which will be the x. So the x will be of two values, the mileage and then the CC, and then the y will just be y2, which will just be the price of the house. So we just go price, so the price of the car. So I'm saying house because I was just from building a model that predicts houses. So just bear with me. So now that you have done that, you can just go reg2 dot I'm going to train our model. So we just create x2 comma y2. We'll train the model right there. So our model now is being trained. So we can go ahead and actually make predictions. So reg.2.predict and then we're going to predict. Let's come up here. We're going to predict the price of this car having a CC of 16,400 and a mileage of let me just copy this so I didn't forget it, of 1980. So we'll move up here. So we'll first provide the mileage and then the CC. So the mileage, this will be a list as well. So providing the mileage and then the CC, which was 16,400. So just run this model. So it predicted that the price of the car is $1,396. Okay. So now let's move and check what is the actual price of that house, of the car, which is for $1,400. So you can see the amazing level of accuracy that our model has. So that's how we can create a multivariate regression and a single variable linear regression using scikit-learn. So I hope this tutorial was helpful for you. If it was, please kindly consider subscribing to this channel and giving this video a thumbs up. So now, before we end up this video, we can also look at the coefficients of this. So now if you look at the coefficients what do you think? We have multiple coefficients, right? Because one coefficient will be the first one, will be the coefficient for the mileage, and then the second coefficient will be the coefficient for the CC, right? And then if you look at the intercept, we just have one intercept, right? As usual, so one intercept, and which is this intercept right here. So you can go ahead and actually write a function just like this, where you provide the values. You take the mileage of the car, you multiply it by the first coefficients, and then the CC of the car you multiply by the second coefficient, and then you add to it the intercept, which is 1405. Okay, and then you'll be able to get the exact values whenever you make a prediction. So that's all I wanted us to discuss in this tutorial. If you find it helpful, please kindly consider liking this video and giving this video a thumbs up. So I have given you a bit of an assignment on my GitHub page, so you can go to my GitHub page. There's a data set that I got from Kaggle. It contains the city, the house, the area, the room, the bedroom, the parking space, and stuff like that. So what I want you to do is that first build two models, right? One model that to predict the price of the house, right? The price of the house whenever you are given the total area of the house, and then build another multivariate linear regression model that will take in the area of the house, the total number of rooms, how many bedrooms are there, the parking spaces, how many parking spaces, and then use that to predict the price of a house. Okay, in using this data set. So you can find this on my GitHub page, and you can read more on how I did that, on how I found the solution to that. Okay, so thanks for watching. If you like this video, kindly consider subscribing to my channel by data set. So in the next video, we'll begin looking at classification model. So this is a linear regression model that can be used to predict values. Okay, so in the next video, we'll look at a classification model that can classify things like whether something can happen or something won't happen, whether a person will buy a car or won't buy a car, whether a person will apply for a loan or won't apply for a loan, right? That's a classification. So that's what we'll be building in the next tutorial. Okay, so see you in the next tutorial. Please kindly consider subscribing to this channel and giving this video a thumbs up. Keep safe. See you in the next tutorial.